Hi, welcome back for another 7 Caillou challenge. This is called Adding Values of Arrays in a Shifted Way. And I always encourage you to read through the instructions, but in this case, I think the best way to illustrate this is with an example. You are given an array of arrays, very appropriately named there, and a shift value. And what you're supposed to do is you will add the values of all the arrays, but with each subsequent array, you're going to shift it. And so you're adding positions vertically. Let's look at this example number 1 below. They give you 2 arrays, right? They give you the values 1 through 6, and then they give you a second array with a bunch of 7s, 1's negative. The shift value is 0 in this case. So the arrays line up vertically, evenly. There's no extra elements. And you simply add 1 plus 7 is 8, 2 plus 7 is 9, 3 plus 7 is 10, etc. Go ahead and finish that and make sure you see what's going on there. But let's look at a couple more examples to see less trivial cases when you actually have a shift value. So in example 2, you have almost the same 2 arrays. For whatever reason, this one's not negative anymore. But you have a shift value of 3. So notice how the second array is offset from the first. So when you go to add, there's no value under the 1, so the final output's 1. There's no value under 2, so you get 2, 3 drops to 3. Finally, you hit 4 and 7. Those add up to 11. 5 and 7 equals 12, etc. Notice the tail of this second array is shifted such that there are no values from the first array, so those 7s just fall in place there. And then one more to really make it clear. They give you 3 arrays, and you can see how this process repeats for 3 arrays. And so you start adding again, 1, 2, 3. Finally, you've got some overlap with 4 and 7 there. You get the 11, 12, 13 values. And then you get some more overlap when the third array kicks in. And finally, you get this output, which I think you can see if you add all these values vertically. So yeah, it's a little challenging for a 7 Caillou, but it's nothing that you can't handle. Just take some time to think about it, pause the video, and come on back when you're ready. So I'm going to get rid of this. We don't need this. So the way I want to go about solving this problem is that I'm going to figure out the size of the final output first. We notice that we're obligated to return an integer array, and you should remember that arrays have fixed sizes. So I'm first going to use the input data to determine the final size of the result. So notice in example 1, when there was no shifting, the output's just the same size as any of the arrays. If you read the description, you'll find out that all of the arrays contained within the array of arrays have the same size. In real life, you would check for that, and also that their sizes are greater than 0, but they guarantee it for this this challenge, so I won't go into the error checking for that, but you would in real life. So that's good, but when you have a shift value, notice that the final output size is bigger than the size of any of the individual arrays, right? These ones were size 6. The final output size is what, 9? 7, 8, 9. Yeah. So you had that overlap of 3. 6 plus 3 is 9. And then you'll notice with the 3 array example, your output size should be 12, right? You got 3 extra here, 3 extra here. So for each array in the collection, you're going to start with the original array size, and you're going to add that shift value because each one is going to shift and add these extra values. I hope that's clear for determining the size of the final output array. So I'm going to have something like that, int array result. So let's use the data to size that properly. We have to say the size of an array when we declare it, right? So we could say to start, we could go int num arrays is going to be equal to array of arrays dot length. We know arrays have a length property. It's the same for an array of arrays. That'll tell us how many arrays are in here. And then if we want the array size, that is the size of any individual array, we can simply say array of arrays at position 0. Remember, they guaranteed us that it's going to be populated with at least one array, so that's why it's safe to automatically index here. In real life, again, you would do checking for that. But we can just check the length of that array in that first position. They're all going to be the same size. So this is just the size of any individual array. Then we know the number of them. So then we could say something like num extra elements would be equal to the number of arrays minus 1. Let me put this in parentheses because I'm going to multiply by the shift value like I described previously. So the number of arrays minus 1, let's use this 3 example where we had 3 input arrays. Notice we're getting 3 extra values for each extra array in the collection. The first one doesn't add anything, right? But once you start shifting, you start to get 3 extra. When you shift again, you get 3 extra. So that's why I said number of arrays minus 1. I'm not counting the first one. And then I'm multiplying by the shift value. So in that case, I would have 2. 3 minus 1 equals 2, right? Times the shift value is 3, which would make 6 extra elements. So when I size my result, I can say new int, and it's going to be the array size, which was 6, plus however many extra elements come in from all the shifting that's done. All right, so we have an integer array ready to use, and C# will take care of populating this with zeros. That's the default value for an integer. So now we have the task of going through our arrays and sort of adding them into each position, but we have to be careful to honor the shift. So I'm going to create an additional variable here called start. And I'm going to initialize it to 0. But what you can imagine is that each time we process an array, we're going to bump this start value by the shift value. So at first we'll start at 0, and we'll process these values into our result. When we're done, we'll bump the start value up to 3. Then we'll process this array, and so it's going to go in. It's not going to go into result at index 0 anymore. It's going to start at 3, then 4, then 5, position 6, etc. And then when we're done with that, we're going to bump it by 3 again. It'll start at position 6, then go index 6, 7, 8, 9, etc. into result. So we can say for each int array, I'll just call it R, in array of arrays. I think you've seen this for each syntax by now in 7Caillou. But it's just another way of for looping without the standard for loop. So we're looking, this is going to give us each array in turn. It's going to give us this array first. It's going to give us, on the second loop, it's going to give us this array. On the third loop, it's going to give us this array. So what we can do with this is, you can imagine we're going to process each array, right? Process array. And then when you're done, like I said, you want to go start plus equals the shift value. And that's the same as saying start equals start plus shift. It's just a nice shorthand for that. So we can process the individual arrays. In this case, I will use a traditional for loop. For int I equals 0, I is less than array.length, increment I, right? The normal for loop you're used to. And so what we can do here then is, like I said, we're going to go into result, and it's important we get the position right here. I'm going to say start plus I, and this is going to give me the offset when I need it. Notice the first time through it's 0, so it's going to start with the result at position 0, which is what we want. And you're just going to add to whatever value is stored at that index, add to it whatever the current value of the array you have is, right? So it's going to go through, all arrays are size 6. It's going to go through in our final answer, start at position 0 and add up whatever values are in the first array. Then we come down, it says start now equals shift, which was 3. So it comes to the top of the loop, it gets the second array now, puts that in this variable ARR. Then it's going to go through ARR from its first value to its last value, and it's going to go into our final answer array. And this time, instead of starting at index 0, it's now going to be 3 plus 0. So it's going to start at 3. And then when this for loop is going to cycle, right? And each time it's going to be 3 plus 0, 3 plus 1, 3 plus 2, 3 plus 3, etc. for all 6 values. And you can see how those values are being added in a shifted way. I hope that's clear. And then finally, when you're done, you should simply be able to return your result. And remember, if any of this is unclear, of course you can ask me questions, but you can also put in console print statements, console write line, rather. Make sure you bring in the system namespace if you need to do that, since it wasn't auto included here. I'm going to hit a test here, see what I did. I hit the green. And we're clear for takeoff. So yeah, you can go ahead and submit that. Again, if you weren't sure and you just wanted to see how this was cycling, you could say console write line. So you want to see which array you're dealing with at any given time. You could say string join. You could say array. And you could say console write line. Start is now. Start. So you can see how that value, that shift value, is being updated each time through the for each loop. Something like that. Again, you're going to have to bring in system namespace if you want to do this. Let's hit the test. Let me see if I can expand this so you can see your statements. And yeah, you could see that first array, 1, 2, 3, 4, 5, 6, then the one that was filled with 7s. Notice the first example test down here. Where is it? It had a shift value of 0. So that's why it always, start is now 0, start is now 0, because you're adding 0 every time. But then you get a second example with a shift of 3. You can see how it goes from 3 to 6. And in that example with 3 arrays, it goes to 3, 6, and 9. And so if those are, like I said, whenever you get stuck, remember to do that. I'm going to take mine back out for the purposes of submission. And good, since I just used Control-Z to undo, it remembered the state here. I'll fire mine off this way. You could, I suppose, condense this if you want, right? Put some of these variable names on the same size. You don't even need to break these out into separate variables. I just think it reads nicely. But you could insert the actual values of these right in place here. You can see how it gets a little clunky. So tried to make it readable. Other than that, yeah, I'll go ahead and fire mine off. Not sure that there's much more to say about it. And then you know what to do. Go through other people's solutions. Here's one for you linkers. Good way to do it using LINQ. Yeah. So go ahead, finish that. If you have questions, you know where to find me. Hit me up. I appreciate the likes and subs. I will see you in another video. Thanks.